Sabi Africa. No Africa. No Africa's pioneering role in science, engineering, and technology.
Sabi African Network, illuminating Africa's narrative as pioneers in science, engineering, and technology.
African textile conservation and dye stabilization, bridging indigenous practice and modern science. Do you know that some of Africa's most celebrated textiles hold centuries of chemistry, engineering, and environmental science woven into their fibers? Today, we are exploring the deep science behind conserving these masterpieces and stabilizing the natural dyes that bring them to life. Natural dyes are beautiful but fragile. Their color depends on delicate chemical structures that react to light, humidity, and oxidative stress. Without careful stabilization, indigo, tannins, and plant-based pigments lose intensity, shift hue, or break down entirely. Conservation starts by understanding the molecular risks. African dyers mastered local chemistry long before modern labs existed. Indigo vats rely on controlled fermentation and pH regulation. Mudcloth uses iron-rich clays and tannin-heavy plant extracts to form stable complexes. These are not just artistic choices, they are sophisticated chemical systems tuned for durability and aesthetic depth. To conserve African textiles, you have to understand how they were made. Indigo sits inside the fiber after oxidation. Mudcloth dyes are anchored by iron tannin complexes. Resistance patterns rely on physical and chemical barriers. Each method creates its own conservation challenges and shapes the strategies experts use to preserve them. Modern conservation uses non-destructive tools to see what the eye can't. Hyperspectral imaging maps fading patterns. Raman and reflectance spectroscopy identify dyes without sampling. SMEDS pinpoints metal mordants and clay residues. These diagnostics guide treatment decisions and ensure interventions stay true to original materials. Stabilizing dyes often means strengthening the bonds between pigment and fiber. Conservators may use gentle plant-based mordants, adjust local pH, or conduct microtreatments to improve fastness. Some objects respond well to UV-absorbing barriers. Others need minimal chemistry and more preventive care. Every textile gets its own treatment plan. The most effective preservation strategy is environmental control. Low light protects indigo. Stable humidity prevents iron tannin complexes from accelerating decay. Clean storage, good mounting, and careful handling slow deterioration far more than invasive treatments. Prevention is the quiet hero of conservation work. Conservation in Africa is not just technical, it is ethical. It is about honoring cultural ownership, using local knowledge, and choosing sustainable materials. Biomordants from plants and agricultural waste replace harmful metals. Training communities strengthens local archives and keeps textiles connected to the people who created them. Adir preservation focuses on light control and structural support. Mudcloth care centers on managing humidity because iron tannin complexes can accelerate fiber decay. Each case shows how indigenous chemistry and modern science meet to extend the life of these textiles without changing their identity. The future lies in blending deep-rooted African dye technologies with cutting-edge analysis. By investing in local capacity, sustainable chemistry, and community-led stewardship, Africa is shaping a global model for ethical, eco-friendly textile conservation. These textiles are not just heritage, they are scientific blueprints worth protecting. Like this video, share your thoughts, and subscribe for more deep dives into African history and science.